Hi, boys and girls. I hope you all have been having a wonderful Labor Day weekend, enjoying that extra day. Here are answers. I'm going to go over, kind of explain. If you have extra questions, please write them down. We can go over them first thing tomorrow before the test. And real quick, shout out to Gavin M. in 3-4 for being that risk taker on Friday during class. You know what I'm talking about. Keep doing that. Keep asking questions. Thank you. All right, so number 1, name all number systems to which 16 over 4 belongs. Remember, first step is to reduce. 16 over 4 is the same as 4. So that's a natural number. Remember, if it's also natural, that smallest box fits into all of those bigger boxes. Think of the stacking boxes and the baskets. So if it's natural, it's also whole. It's also an integer. It's also rational, and it's also real. Okay, name all the number systems to which negative 5.7 belongs. It is a negative number, but because we have that decimal, it is not an integer. So an integer is positive and negative whole numbers. That smaller box fits into the bigger box, but a bigger box cannot fit into a smaller box. I'm going to draw the diagram a little bit later, but this is only a rational number and a real number. All right, number 3. So we see a pattern, but just because there's a pattern does not mean that we can copy and paste. It's not repeating. We can't take this section here and just copy and paste that again. We need to add in extra information because now we start adding more. So this is non-repeating, non-ending. So this is an irrational number and a real number. And then negative 5 over 5, we've reduced first. Negative 5 over 5 is equal to negative 1. Negative 1 is an integer, a rational number, and a real number. All right, so remember we have our biggest box here. Okay, so these are all reals. And then over here, we've got this smaller box. This is irrational. And in this bigger box here is rational. And then within that box, we have integers. Sorry, this handwriting is so horrible. And then within that box, it fits in there is whole numbers. And then inside that box is natural. The smaller boxes are inside each of the bigger boxes. But the bigger box cannot fit inside a small box. So a natural number is also a whole number, is also an integer, is also a rational. But not all rational numbers are natural numbers. Draw this diagram. Remember, I know in period 3-4 we said Rudolph is winning naturally. Rudolph is winning naturally. Remember which order they go in. All right, so that was our real number system. All right, now we have to order these. Okay, so these first two are in ascending order. Stack. Please remember to stack. All right, so we've got 12.06. Decimal point. Remember, I'm going to do the positives and negatives separately. And then here are our negatives, negative 15.8. And then I've got negative 15.49. Ascending is least to greatest. Okay, so these are the same, these are the same. So now we have to go over to this column here, which is smaller, negative 8 or negative 4. Draw the number line. Negative 4 is closer to 0 than negative 8, so negative 8 is smaller. Think about the jelly beans. You all know, and I asked you all individually, which is smaller, negative 8 or negative 4? And then I draw the number line. I say, which is further from 0? You say negative 8. If I ask you about the jelly beans, which one would you dislike more? You would say negative 8. Use those to help you. Don't just assume you know. Stop and think about it. So then we've got negative 15.49. These are the same. So let's look over here, which is smaller, as 0 is smaller, so 12.06, and then 12.3, and this is our answer. All right, ascending order. We got to first convert these to decimals. This has a decimal in it, but it is not the decimal form. We got to take the decimal point You can either move it twice to the left or divide by 100. So we get negative 0.2562. Here, this negative 1 tells us we're moving 1 to the left, so that's 0.208. Negative 0.3 repeating. And then we've got negative 0.4. So we only have one positive, the other three are negative. So obviously this number here is going to be our last number. Let's stack our other numbers. Okay. So hard to write with this little thing here. All right, so these are all negative. These are all 0, so we go to our next column here, which is smaller, a negative 2, a negative 3, or a negative 4. Good, negative 4 is the smallest. Next, negative 3 or negative 2, which is smaller. Negative 3 is smaller. And then we've got negative 25.62%. And finally, our only positive. So whenever it's asking you to order scientific notation, convert them first. That's always our first step, is to convert. You can also use your calculator to convert these. Okay, some of them. If the numbers are too big or too small, it won't work with your calculator. All right. Moving along quickly. Number 7 and 8. Now we're putting these in descending order, which is from greatest to least. First, we have to convert to a decimal. So negative 14 over 5 as a decimal is negative 2.8. Okay. 1 2/3 as a decimal is 1.666. Repeating. 120% as a decimal, divide it by 100, and we get 1.2. And then negative 1 4/9 is negative 1.4, repeating. Descending, greatest to least. Obviously, our positives are bigger, so let's start over here. The ones are the same, so let's look over here in the next column. Which is bigger, a 6 or a 2? A 6 is bigger. So 1 2/3. And then we have the 120%. Okay, over here, which is bigger, a negative 2 or a negative 1? Careful, which is bigger? This is where we always want to make mistakes. Stop and think about it. Draw a number line. Boys and girls, this is your first test. This is a big deal because this is going to kind of set the tone for the rest of the 9 weeks, maybe the rest of the year. I know that all of you in class, when I give you the correct prompts and I guide you, are able to get this correct. Do those prompts yourself. Draw your number line. Think about the jelly beans. Don't just try to rush through and say, yeah, I know this. You do know it, but you have to take your time and do the work. So which is bigger? Negative 2 or negative 1, which would mean that you like it more. A negative 1 would mean you like it more. And then negative 14 over 5. And that is our answer. Okay, number 8. So we've got 62.31. Move it over twice or divide by 100. So 0.6231. Negative 1/6 is negative 0.16 repeating. Negative 18.75, move it over twice to the left or divide by 100. And then negative 0.66 repeating. Descending, greatest to least, so we're going to start with our positives. They're both 0, both 6, so third column, which is bigger, a 2 or a 6? A 6 is bigger, so 0.66 repeating is first. Then our next positive. Okay, over here, both zeros, both 1s, so let's look at our third column now. Which is bigger, a negative 6 or a negative 8? Which one would mean that you like it more? Draw your number line. Okay, which one is closer to 0 now? Which one would mean I like that jelly bean more? A negative 6 is, so negative 6 is bigger. And then negative 18.75%. And that's our answer. Do the work. All right, inequality signs. Remember, this is less than, this is greater than. We want to eat the bigger number. First, we convert them all to a decimal. So they're same thing, stack them. They're negatives. They both have a 1 over here in this column, which is smaller, -2 or -8. And -8 is smaller, so we're going to open up this way. Over here we've got -3 repeating, and this is -0.204. Stack them. When we stack them here, okay, these are the same. Let's look over here in this column, which is smaller, a -3 or -2. Draw your number lines. Feel like a broken record. Do these things. I want to see these things tomorrow. Which is further from 0. -3 is further, so that's the smaller number, so we're opening that way. Good. All right, we're getting close. Scientific notation. Proper scientific notation is one number to the left of the decimal point. That one number is between 1 and 9 times 10, and then the exponent is the number of times we move the decimal point. First, we find our decimal point, which is here. We go 1, 2, 3, 4, 5, 6. We're going to stop here because then we'll have one number to the left. And then I've lost count. I forgot how many. That was 7, right? All right, times 10 to the 7th. It's a positive 7 because this original number is a very large number. Over here we find our decimal. 1, 2, 3, 4, 5. I stop after the 7 because now I've got one number to the left that's between 1 and 10. Times 10 to the -5th. Why is it negative? Well, because this original number is a very small number. All right, write it in proper standard form. It's also called standard decimal notation. Same thing, standard form, standard decimal notation. Negative exponent means we're moving to the left. Think on our number line. Here's 0. We've got our positives and our negatives. So we're going to take our number. Take the decimal point, we're going to move it 1, 2, 3, 4 times to the left. And then we fill in with zeros. And then you rewrite your number. Do not leave it like that. Make sure you rewrite it. 5.07. We're going to move 5 times to the right this time, because that's where our positives are. 1, 2, 3, 4, 5. Fill in our zeros. And we rewrite it. Remember, don't leave it like that with all your squiggles and everything. Rewrite the number. All right, you guys are doing well with scientific notation. Remember, one number to the left of the decimal point between 1 and 10. If it's a very large number, we've got positive exponents. If it's a very small number, we've got negative. And then when we're converting from scientific notation to standard, positive numbers go to the right, negative exponents to the left. Last two. Difference. What does difference mean? We're going to subtract. So we have to subtract 390,000 minus 7,000. So we subtract those and we get 383,000. Now it says express your final answer in scientific notation. Here's our decimal point, 1, 2, 3, 4, 5. So the answer is 3.83 times 10 to the positive fifth. And 14, last problem, we made it, is negative 11.00007 times 10 to the negative third in proper scientific notation. No! Because why? Well, this number here, right here, that's not allowed. That's not legal. We can't have two numbers over here to the left of the decimal point. Is that number, is that 11 in between 1 and 9? No, it's allowed to be negative. The negative right here, that's allowed. This would need to look like this though. Okay, and then This would be into the negative second now. So we would need to have, this would be in proper scientific notation now with only one number to the left of the decimal point. Now that 1 is in between 1 and 9. You can't have two numbers here to the left of the decimal point. All right. Any questions? Chat me in Remind. Send me comments on Schoology. We will take a few minutes to review before the test tomorrow in class, but I want to give you as much time as possible. All right, you guys got this. Just do your work. Stop and think about it. Don't rush. Bye.